Very good morning, friends and students. In today's lecture, we are going to see the concepts of red block trees and introduction, and we'll also cover the concepts of splay trees. Okay, so in the previous lecture, we have seen a few things about AVL trees. Okay, AVL trees are height balanced binary search tree, we can call, and the difference between this AVL tree, the issues in the AVL tree is that AVL tree will always favors the search time complexity of big O of log n. It is also called as a strictly balanced binary search tree. Okay, and the problem with the AVL tree is the calculation of balance factor when the each and every node is inserted into the tree. That is the first problem. The next is that even if you insert a single node, you need to do lot of rotations which will affect the structure of the tree. It is very complex, okay, considering it. So to overcome these issues, we are coming for this tree called as an red black tree. Okay, instead of balancing factor here, the nodes of the tree are colored with reds and blacks. Okay, so these reds and blacks are used to balance the height in the red black tree instead of the balancing factor that we have in AVL tree. So the disadvantage of AVL tree is that it is very complicated when we are doing keep on doing the rotations, but it is very efficient in terms of searching. Okay, whenever we are coming for the red black tree, it is called as a relaxed version of height balanced binary search tree. Okay, if you compare the complexity of searching in red black trees and AVL trees, AVL tree will have a better search complexity than red black trees. Red black trees are little bit relaxed version. Okay, where the advantage lies is that it is less complicated. We will not do much of those rotation operation, so this is less complicated. But AVL tree are very much complicated, so we can decide based on our use cases. Do you think that I need a good searching efficiency, then you go for AVL tree. If you think that I need less complicated operations to be exist on the tree, then you go for red black trees. You need to compromise on the search time complexity, not much, more or less. Okay, so that's the use of this red black tree. Okay, now as I said already that this red black trees are colored with reds and blacks. Okay, so how do we color this reds and blacks, and how do we check that particular tree is balanced or not? That's what we are going to see that. Okay, so first and foremost thing is you need to remember this carefully. These are the properties of a red black tree. Okay, if there is a root node, that root node is must be colored in the color black. Okay, so that's the first property. The next property is that if you are going to insert a new node other than the root node, so I have a root node, the next node that you are inserting, so that the node that is new node, I will call it as a new node. Whenever you are inserting a new node, then that particular node is colored in the red color. Okay, and one more condition is that you should not have more than two red color nodes adjacent to each other. Okay, so that's the second condition. Okay, so you have a tree. The third condition is that you have a tree. Okay, you have the path to the from the root node to the leaf node. Okay, you can take any path from the root node to the leaf node, and all those number of uh, black color nodes should be equal in all the paths. If we count the black color nodes from the root to any leaves, okay, in the entire tree, the number of black nodes should be equivalent in all the roots. Okay, that's the three condition that we see. The next thing that we are going to see is how do we color the node. So consider that, sir, I have two adjacent nodes of red color, so what can I do to overcome this? You should not have like that, but what we can do, so you have two things to overcome this complication. The first one is what we call as recoloring, or else you can go for rebalancing. Rebalancing is once again a kind of rotation. You have two options. One is a recoloring, another one is what we call as rebalancing. These two options are there to balance the red black trees. Okay, so these are the operations: insertion, deletion, and searching. searching is same as what we have seen in the AVL tree. So if the node is greater than the root node, it goes to the right, and if the node is lesser than the root node, it goes to the left. Okay, so the difference here is that insertion and deletion that we will see in today's lecture. Okay, now so all the nodes, either it will be colored in the red color or else the black color. Okay, now we will see the procedure, and once we read this procedure, we will go and experiment the same thing in the animation. Okay, I will show you the animation also. So consider initially there were no nodes in the red black tree, so I am going to insert a simple node. As I said already that if we are inserting any new node, it is colored as in the red color. But one exception is there: if that particular node is a root node, then you can color it as in black. Okay, so if we insert a single node into the red black tree, then that particular node will be of a black color. Okay, next if I am inserting one more node, say I inserted 10, now I am inserting one more node, say the node is the node is 20. So if I am inserting the new node, then that particular node should take the color of red. So we'll have two nodes right now, 10 and 20. 10 is of color black and 20 is of color red. So next if I am going to insert one more node, say color, so the node number is say 30. So 10, the root node is black, 20 is the red color, okay, and 30 is once again a new node. I am going to insert that 30th node in the left node, okay, sorry, into the right. So if you see 10, 20 and 30, the colors are black, red and red. So which is the newly inserted node? If you remember, the newly inserted node is 30. Okay, the parent of that particular node is 20. Okay, so one more thing is that I want to tell you is that, so each node will have two pointer variables associated with it, that is left and right. Okay, the left node is always considered as, means the left node is empty for the leaf node. Okay, means the left will be pointing to null and the right also will be pointing to null. If we take a leaf node, will have the value only, the left and right are pointed to null values. The null values are colored as black. For example, remember carefully, the null values are colored as black. Okay, so for example, I will take one thing here. So you see this, the 10 node. Okay, first we inserted 10, next we inserted say 20, node number 20, next we inserted say node number 30. Okay, so this is black node. Okay, this is black node, this is red, and this is also a red node. Okay, now you see this, the 30th, the 30 is the leaf node. The leaf node will have two things, right? The left and right. The left is null. Okay, I put it as a box. The right is also null. This is also a null. So if you take this 10 node, you see this here, what we'll have here is, here also will have null, this 20 here also will have null. Okay, the left node, all of them are null. So here all null nodes are considered as a black node. Here this is also black node, this is also black node. Okay, now listen, so this is the red node. Okay, you see this, who is the parent of 30? The parent of 30 is 20. Okay, 20 is the parent of 30. Okay, this 20 is of color red. Okay, what is the uncle's color? You check the uncle color, this is red, uncle is the null, null is always black, so here it is black. So here is black and red, these are dissimilar colors. You see this black and red. In this situation you need to do a rotation. Which kind of rotation? Once again, it is a left rotation you need to do. So if you do the left rotation, how it will behave? So you will get 20 at the root node, and left node is say 10, and the right node is once again 30. Now listen carefully, that this can be a black node as usual, you know that very well. This root node is always black, and the node that you have inserted latest will be of red, and in the same level you can also have a red node. So these two are colored as red. This is the first condition. Okay, so where you can insert, okay, you need to check the uncle of your parent. Okay, who is the uncle? You see this a 20, we'll have 20 here. 20 is uncle, there was no uncle, so it is a null node. A null node are always black in color. You check the parent and the uncle. The parent is of a color red, uncle is of color black. These are dissimilar colors. So what you need to do is you need to do a left rotation. In this case it is a left rotation, so you need to do. That's what explained in this particular slide. Okay. So we will see one more condition. Say I'll have a node 20 here. Okay, this is the root node. Next is where we have 10. Okay, so here say consider we'll have 30, and right now, okay, these will be of red color. Okay, this is red and this is red. That's what we'll see. This is of black color. Now I want to insert one more node. Let's say the node is say 40. I want to insert say 40th node. 40th node will come to the right side of the 30th node. You know that very well. So once again you see this is the red color. So whenever a new node is inserted, that particular node is of color red. Okay, so here you see this red and red, this is a conflict. So what you need to do, you need to do some operations to overcome this conflict. Now what you need to do is you need to check its parent. Who is the parent? Parent is 30. 30 is of color red. Okay, and also you need to check its uncle. Okay, so who is your uncle of 30? 30 is the uncle is 10. Okay, you check the color of them. Both of them are in red color. So you see this, both of them are in similar color. In this case what you will do is you do recoloring. If it is of a different color, then you do the rebalancing. If it is of a same color, then you will do what? Recoloring. So here you put it as black, here also you put it as black. Okay, now I said one more condition, that starting from the root node to the leaf node, you count the number of black nodes. You see this, will have two parts here, 20, 30 and 40. You see this, black color one node, black color two nodes. So in this part there is only two black color node. In the left side you see this is the root node, this is the left side. Here also I will have only two nodes, 1 and 2, so you count it, so 2 and 2, so the condition is once again satisfied. Okay, so this is how we will do either recoloring or else rebalancing. You need to check your parents and parents uncle color. These two things you need to check, parent and parents uncle color. If both of them are different, then you do rotation. If both of them are same color, then you do recoloring. Okay, so now at this scenario, these two nodes will become black color, and the newly inserted node becomes a red color. Okay, so we are going to illustrate the red black trees. Okay, so I will be inserting the node 10 into the red black tree. You see this, as I said already, the new node is once again a red node, but one exception is that if that particular node is a root node, then it is colored as a black node. So next is the node 20. Okay, node 20 will be newly inserted, so 20 is greater than 10. As the property of the binary search tree, it is like here you need to insert it to the right side node. Next I am inserting 30. You see this, the violation will happen here. The violation is that no adjacent node should be of the same red color. You see this, here the violation is happened. Next, what you will check, you will check the uncle node. You will check the uncle node. If the uncle node is of different color, then what you will do, you will do a rotation. Okay, here the rotation that we are doing is the left rotation. Okay, we have done the left rotation. Next I am going to insert 40. Listen to this carefully. Here it will be checking this, it will check this, and once again it will check this. So here you see this, these two are of same color. Previously it was same color, right? So if it is the same color, what you need to do, you need to do a recoloring. So you see this is the recolored one. So you see this, you take this path 20 and 10. How many black nodes? Two nodes. If you take this path also, two nodes. Okay, 1 and 2, two black nodes. Once again, the condition satisfies for the red black tree. Next, suppose I want to insert the node 50. Okay, you see this here, it will check here, it will go here. Once again, it will be inserting at this. The violation is both nodes are of same color. So here you see this uncle here is of different color. So here rotation happened. Okay, so rotation happened at this particular node. These are black and these two are newly inserted. That is 50. This is of color red. Okay, once again we will insert, say 60. We'll insert 60, 20, 40 will be checked, 50 will be checked, and here it will come. You see this, these two are what, of same color, right? Okay, same color means what you need to do, you need to do a recoloring. Okay, and now see the difference. Previously in the AVL trees you have strictly height balanced. Okay, first you need to fill the level 0, level 1, level 2, level 3, but here we haven't filled the level 3. You see this, here you can accommodate two more nodes, right? Two more nodes you can accommodate, but it is extended to the next level. This is not strictly by a balanced binary search tree. This is a relaxed version of a balanced binary search tree. Okay, so but here the issue is that the complexity of the rotation is very much reduced, but in the AVL tree you will have more complexity. Every time you will be doing the rebalancing immediately. Okay, that will increase the complexity. That's the issue. So next we will insert 70. Okay, you see this here, it will go check it here. Once again you check it here, it goes to a node 70 at this position, both violation. Then you check this, what you will do, you will do a right, left rotation. Okay, so this is the red black tree. Now, okay, next what we are going to do is we are going to do a deletion. Okay, so I want to delete the node 70. The 70 is at the leaf node. So let us check this, how it will be deleted. First you need to search it, search. Okay, search it, and it will go to the node 70. It is a leaf node. It is just like that, you can delete it. Okay, so leaf node, it is once again the color is red, you can straight away delete it. Now once again I'll delete the node 60. Okay, 60, you check it, the node 60. Okay, you see this here, the left child is of black color, right child is of red color. Okay, so you see this, in this case, okay, the child will be moved to the previous position and it should be colored as the black. Okay, now once again I want to delete the node 40. For example, I want to do, this is having two black nodes, right? Two black nodes. If it is a two black nodes, the predecessor, okay, in order predecessor is 30, that will come to that, and this will be colored as the, okay, this will be colored as the first it will be colored as the red, and it will be what, a new node. So here you check this, the balancing will not happen. So once again what you need to do is you need to do the recoloring. That's why this particular node becomes black and the leaf node will becomes red. Okay, so this is all about the red black tree. Okay, so in the next lecture we will be seeing the splay trees. Okay, thank you.